am having the loveliest time. Everyone should build a boat.
All right, Ryan, you're on. Hello everybody, I am Ben from Team Panic, and today we're doing BattleBoats. Basically, Ryan from Spinnerproof did his own boat out of combat robot parts, and he has put out a challenge for other people to do the same. So today we're going to be building two of them. One is going to be a Ryan style ball of hot glue with a YOLO drive paddle system, and the other one is going to be a more traditional kind of ant weight style version. So I'm going to try and build it the same way I will build any regular ant weight combat robot, which means a 3D printed shell, 3D printed paddles or wheels, and the regular electronics you'd put into an ant weight. I want to see if I can get it into 150 grams. I don't think I will. I'm kind of giving myself maybe 250 grams to build a battle boat out of. But I think the first thing that I want to try and do is to do the bodged version. So to do that, we're going to need to grab a whole bunch of stuff. Alright, so I've got my hot glue gun warming up. I've also got my tub that's going to form the base of this, and I think pretty much everything else I'll need. I've got some extra plastic here to make some, like a bow at the front of the ship, and then I've also got this, which was a semi-successful airboat that I made a little while ago. We don't really care too much about the airboat. The only thing we care about are these motors. I'm really hoping that these motors are still okay. They got put through a lot of salt water, and the contacts down here are a little bit janky, but I'm going to cut those off and put new contacts on them. But I'm really hoping that the actual copper and stuff inside here is still fine. It should be. It's enameled wire. It shouldn't have had too much problems. The motors still spin totally fine. So fingers crossed, hoping that that's all okay. But those are the motors we're going to use to do this, because they've been wet once, so what's a little bit more water, hey? Anyway, for now, actually don't need that, because we need to make sure all of our electronics are going to fit inside here. I'm going to use a bigger battery than I would with an ant weight, just because basically I'm going to seal this thing in, and then we're not going to touch it again for a while, and when we do touch it again, it's going to be completely unsealed. So I want to make sure I've got enough battery life in this thing to do everything I want to do. Which includes, hopefully, having a couple of fights with it. So we'll probably end up putting some form of weapon on this as well. I'm not really sure how that's going to work yet, but that's part of the plan, so we'll see how we go. Alright, is that everything? Yes. Cool, okay. Battery and all of that stack up. Oh, swimming in room. So much room in there. That's awesome. Okay, we can definitely fit in all of the things that we want. Beautiful. So now we're going to need to start work on the front section. So what I was thinking was using some of this to make like the curved bent bow at the front. But I might grab some wire to loop around the front here first to give us a bit more shape. Alright, so that's given our boat some shape, kind of. I think it's a little bit skew-if. I don't think it's actually straight, which, I mean, I think that's going to be the least of this thing's problems, to be perfectly honest. Yeah, so that's given us a little bow. I might throw some foam in the front there. Oh, that was a bit squeaky. So I can put a servo up the front to mount some form of like flipper or hammer something. This should be relatively well waterproof now, but the foam will just keep whatever I put up the front here off any water that gets in. And the next trick is going to be working out how on earth I mount brushless motors to the outside of this thing, because I kind of didn't want to 3D print anything to do that, but it might be the easiest way to go. Alright, I've worked it out. When in doubt, go with what you know. So what I'm going to do is I'm going to use these, which are old 3D prints, but I'm just going to use them as buffers on the side to kind of like sit in under here. And then we're going to mount up a carbon fiber drone arm, because I love these things and they are actually quite useful. So that all together will give us our motor position. So it's going to sit up at the back here somewhere, so we can still get to the screws when we need to. That should actually do the trick pretty nicely, I think. They're gonna have a little bit of camber, which I have no idea how any of this is gonna go. There's, yeah, a lot of very dodgy things going on in this build. Well, this might go down in history as one of the jankiest builds I have ever done. These carbon fiber drone arms don't actually fit these 1806s, so I've had to file them down a little bit, and each 1806 is held on with a single screw in the back and then a bunch of hot glue around the top to keep them somewhat in place. They're also not particularly well lined up. They're on angles. This is all just going to go really badly. And to add to the jank factor, I've had my worst idea yet, and instead of making better paddle wheels, I've done this. This is the fan that I used to blow along that other toy boat that I made, and it has now been melted and turned into a paddle wheel. So that's that guy. God. There is no way this thing goes in any form of straight line. Oh no. I've also got myself set up, so I've got my lid now with holes in it, and I've got some extra cabling so that I can plug all this stuff together. I think it's time to do final assembly. Okay, so this thing is ridiculous and it seems to work. So tomorrow I'm going to take it out and we're actually going to put it in a bigger lake and we're going to give it a shot. But it's a battle boat. It needs something to compete against. So I have 3D printed this. This is a 3D printed chassis using N20 gear motors. This is a lot closer to what I would consider a regular ant weight. I'm going to build this off camera because I think this video is getting a little bit long, and also my camera is actually running out of battery, so I can't really do a time lapse. But yeah, it's going to have my regular Arduino set up in the middle here with some N20 motors and some paddle wheels like this. I'm also going to try and put a servo in here, maybe as a flipper, maybe as like an axe weapon. This guy was supposed to have a weapon as well, but it's already way too heavy, and I couldn't quite work out how to get a good system for having a full servo wire come out through the top of the lid. So yeah, we're going to do the servo weapon on this one and this one only, and we'll see how we get on. So that was interesting and was not anything like what I expected. The white 3D printed boat, it got water into it really quickly. I'm not 100% sure if that was to do with the switch or to do with the fact that the motors stick out the side of the thing. So I tried to seal them up as best I could, but of course there are spinning bits and gears in there. So I tried not to get too close with the hot glue, and one of those two things let water in, and it's basically fried the receiver in here, which, yeah, that wasn't good. Probably should have just hot glued all over the receiver in that, and it might have been okay. On the other hand, the jankiest thing I've ever built actually worked. I mean, it worked better when there was weight in the front of it, and it worked better when it was going in reverse. But it did indeed actually do things. Yeah, and it didn't actually get any water in it at all, which was really fascinating. The other thing too is that because of the way everything sat down in the water, the blade was fighting itself. So the part that was on the bottom pushing water was also like pushing water that way. There was also parts of the top of the blade in the water pushing water back that way. So the blade was fighting itself. It meant that the whole thing went a lot slower than it should have done, considering that it has essentially YOLO drive paddles. So I want to try and fix this a little bit, and I think the easiest way to do that would be a strip of foam all the way down the middle and out the back, and maybe even an extra little bit in between the two blades, just to kind of prop the blades up out of the water so only the tips of the blade actually hit the water. Maybe that'll help. This white guy I think is just not salvageable. I will need to redo the entire design of this thing, move the motors and the switch to the top, like outside the main box. It will help, and it will mean that there's less ports that need to be sealed up and stuff. So this, yeah, we're not going to go anywhere further with this in this video. But if you guys want to see me do some more battle boats, and in particular build another version like this that I could put 3D files up for so that you guys could print your own, let me know in the comments down below. If enough of you guys want to see some more battle boat stuff, I'll happily do another episode of this, and we'll get a proper 3D printed ant weight-ish battle boat going. But for now, I'm going to throw some foam under here, and then we're going to go test it. But unfortunately, we're not going to go test it at the lake because, yeah, it's winter here, and winter is doing its wintry thing, so I think the best case scenario for us is the bathtub. So that worked better-ish with a giant hunk of foam hot glued to the bottom of it. Also, it kind of got hot glued at a bit of an angle, but that kind of means it's got a nice little stand now that just kind of makes it sit there quite nicely. So yeah, I mean, I think that's about as good as I'm going to get this boat. I did rip the weights out of the front and do a test without the weights to see if it would stop kind of nose plunging into the ground. And actually what it made it do was stand on end again. So yeah, there's no winning here. I think I'd need to glue the weights back in the front, and also probably extend this piece of foam up this way a little bit, and that might make this thing work. But the brief times where it was sitting up out of the water and it was just had the sections of the paddle in the water, it was working exactly as I was expecting. It seems that for whatever reason, when there's too much water over these paddles or even in the motor, it does bog everything down quite a lot. And weirdly, unlike when you do this with just wheels straight on there pushing an ant weight, the motors don't seem to twitch like they do with the wheels when they've got a paddle on them. I don't know what that is. Maybe it just needs less power to push a paddle through water than it does to drive a wheel along the ground. Not 100% sure, but it does work better like this than it does with wheels. Yeah, so there you go. That was interesting. That was a lot of fun. Like I said before, if you guys want me to try again with the 3D printed version, let me know in the comments down below. And I hope you guys have enjoyed that one, and I will see you in the next video.